This is part of the spec. We can see that we have to look at weathering, mass movement, erosion, transportation, and deposition. So these photographs, what have these photographs got in common? We could see the Sphinx and the pyramid, one of the pyramids of Giza in Egypt. This is a big cliff, and these are what are called scree slopes. And this is called the Green Bridge of Wales in Pembrokeshire. Obviously, this cliff here and the scree slopes is natural, as is the arch. This obviously is a human part of the built landscape, albeit an ancient one. But here's the answer, really, that all these are showing evidence of geomorphic processes. There are natural processes that are at work that are shaping the surface of the earth. So the Sphinx has been weathered. It's been weathered. Originally, the Sphinx had a beard here, and the face has been weathered over possibly about 3,000 years. Weathering and maybe some wind erosion has also affected this. This cliff has been attacked by what's called freeze-thaw weathering, and that has caused bits of rock, the cliff face, to break off and fall down hill, forming these huge piles of loose stones called scree slopes. And then the arch over here has been eroded by the waves, as well as being broken up by weathering. So all these processes are slowly changing the shape of the land, the surface, and also changing the appearance very slowly. So one science that you can study at university is geomorphology. Geomorphology is the study of landforms. It's a study of how the landscape is changed due to natural processes. The word geo is the earth, the word morphology is the shape. That means that this here, geomorphic processes, means earth shaping processes. A process is a series of actions that repeats. We're going to look at these 5 categories of geomorphic processes. These are the ones that were mentioned in the spec: weathering, mass movement, erosion, transportation, and deposition. And all these 5 processes are naturally recurring, and they change landscapes. Imagine this is your house. What would need repairing, and why does it need repair? The tiles slowly get weathered and they break up, and eventually a roof needs to be repaired. Frost can get into these bricks, this block paving, and can cause the block paving to move around. So we can see evidence of weathering on houses, on paints, windows, bricks. The whole thing can be weathered. And also these bushes over here, the roots can grow, and that can cause bricks to move. If you have a tree, for example, we often see this form of what's called biological weathering. If you have a tree near a pavement, the tree roots grow, and as they grow, they get larger and they cause the pavement to split. And you might have seen this before. We'll start having a look at weathering. So weathering is the in situ, that's the in place, disintegration and breakdown or breakup of rocks. It's when rocks get broken up, not because of waves or the sea, the wind. It's just literally because of an exposure to the atmosphere. There are 3 main types of weathering, 3 main types of breakup. One is chemical, one is mechanical, and one is biological. Chemical weathering, well, if there are rocks which are carbonate, they're alkali rocks such as limestone or chalk, they will dissolve when they're in contact with water. And this process actually is called carbonation. It's when weak carbonic acid, which is rainfall, what happens is as the rain falls through the atmosphere, it absorbs some carbon dioxide, and that turns it into weak carbonic acid, which can literally dissolve chalk surfaces or limestone surfaces. That's called chemical weathering. That's a form of chemical solution, but really we call that carbonation. It's chemical weathering. Great example of that. Mechanical weathering is when the rocks are actually moving around, and because of the movement they start to split. One of the most well-known ones is freeze-thaw weathering. Water gets into a crack, it freezes and it expands in volume, and this repeated process causes the rocks to split apart. And you find this in cold places or places that are high altitude places where there's lots of ice in the winter and the rocks can be split apart. And that's what formed those scree slopes in the previous slide. And then this is biological weathering. This is where plants or roots or animals grow or change. The life is at work, causing rocks to split. Great picture of a tree here. The roots are growing into that rock. As the roots get bigger, the rock is being split apart and breaking up. So weathering is when the rocks get broken up. There's some more examples here, more nice pictures here. Here's our pictures of freeze-thaw weathering, which is mechanical weathering, sometimes called physical weathering. It's all to do with the splitting because of movement. Biological weathering is because of roots growing into trees or animals burrowing into soil. Chemical weathering, this statue has become slowly weathered over time. Our second category is mass movements. Well, once material has been broken up or disintegrated because of weathering, it can then move downhill because it's loose. So weathering produces a vast quantity of loose rock material which can then flow downhill. And there are two main types of movement. One is a fall, a rock fall, and this is where you have a steep vertical cliff and the rocks fall down, forming a scree slope. And that's what we saw in that previous picture, or those huge piles of loose rocks which had fallen down the cliff and been piling down around the base of a cliff. We see this frequently in mountainous areas, as I said before, high elevation areas where the weather is cold and ice can form. A slide is where you have blocks which are sliding down, hence the obvious term there. And for this to happen, you have to have bedding planes. The bedding planes are the layers of sedimentary rock. And as you should remember from science, sedimentary rock is deposited in layers, in horizontal layers. And tectonic movements can cause these bedding planes, these layers, these horizontal layers, to become tilted at a steeper angle. And on this picture here, these were originally horizontal. They have been tilted up, and then as these blocks are removed, they can, and loosened by weathering, the break up of rock, they can then slide downhill. Remember that you can't get any mass movements unless you've had weathering. And this is a slump. Now, slumps only happen in very loose, weak type rock where the structure is weak. Now, clay is an example of rock which can slump, especially when it gets wet. It can lose its cohesion, its strength, and the weight of wet clay can cause it to slump down in huge slices. This is called a rotational slip. On this picture, it's hard to see, but you can see a slump has happened in that area there, where the cliff has slumped down. This clay has become wet, it's become heavy, it's lost its strength, and it's slid downhill. Here's a summary sheet for weathering. Weathering, I've put in a purple font. Chemical weathering, which we talked about being carbonation, the rainwater dissolving the carbonate rocks such as limestone or chalk. We said the physical weathering was when the rock gets moved, for example, freeze-thaw weathering. And we said biological weathering is when there's animals, fauna, burrowing into soft rocks, or you have plants, flora, the roots grow into soil, into rocks. As they grow, they split apart the rocks. This slide also shows mass movements, but in green, and it's the movement of that loosened, weathered material downhill due to gravity. And remember, we said vertical cliffs, you get rock falls, and if you have weak rocks like clay, you can get slumps. This is quite an important distinction because lots of people get confused between weathering and erosion. And this slide shows us that weathering is not the same as erosion. Erosion implies or means an active wearing away by four main agents of erosion: rivers, the sea, wind, water and ice. But weathering is not. There's nothing actually wearing away. For erosion to happen, you have to have something which is wearing away. Well, weathering, there's nothing that's wearing it away. There's no agent which is actually doing the work. It is the exposure to the atmosphere or plants. How does weathering help the process of erosion? Well, as I've explained to you just now, the weathering breaks up the rocks, it disintegrates the rocks, and it makes them therefore easier to erode because they're loose. They can be easily worn down and then removed, taken away. So let's look at erosion itself. There are four main types of erosion. These are abrasion, hydraulic action, solution and attrition. Next slide tries to define each one. Abrasion then is when moving rocks, these are rocks that could be moving within waves or they could be moving by rivers, and they are scraped against the movement of the water causes these rocks to be scraped against rock surfaces, and we can call this sandpaper erosion. Hydraulic action is when the moving water can get into cracks, and it can cause an increased pressure, water pressure or air pressure into cracks, and the cracks are going to get wider and then bits of rock can get broken off. Solution is similar to what we said before. It's the dissolving of carbonate, which are alkali rocks, by acidic river water. Attrition is quite a violent process where small rocks or pebbles collide, they smash up into fragments, and then the rough edges get smoothed off. If you go to any beach by the sea and you find lots of round pebbles, well, that is what I mean by attrition. When you see a round pebble, you know that attrition has been at work because those were once rough edges and it's now a very smooth surface. This diagram shows us something about coastal erosion. It shows us how both things work together. We can see up here you might have some weathering attacking the rocks and causing them to break up. And then the waves down here, this is where you might have your abrasion, your hydraulic action, causing the weathered rocks to be broken and moved away. Let's then have a quick look at a summary of the four erosion processes we have. Hydraulic action, which was the water and air forced the cracks get bigger and then they break off. You have abrasion. Abrasion is when rocks are thrown against rock surfaces and it causes the grinding down of the rock surfaces. It's a bit like sandpaper erosion. Attrition is where the pebbles are colliding together and they are smashing up into small fragments, or the rough edges are getting knocked off, becoming smaller and smoother in the process. And solution, that's that acidic rainwater which is dissolving surfaces, rock surfaces such as chalk or limestone. One important thing about erosion is that erosion requires movement, and that requires energy to happen. And if there's no energy, there's going to be no erosion. Right, transportation. There are four main ways that water, which is rivers or waves, can transport sediment. Again, for transportation to happen, you have to have lots of energy to actually move things. And the bigger the item, the bigger the stones, the more energy is required. So we look at traction. Traction happens when there are pebbles or rocks that are so big they can't be lifted by river flow or waves. And so these items, these pebbles or sediment, they are rolled. So traction is when these are rolled along. Saltation is when the rocks are a bit smaller and they can be lifted and they bounce along in a river, or they might bounce along in waves. Suspension happens when items are very, very small. They're so small they can float. They can float along. So if you look at most rivers look quite murky. We might think this is because of pollution, but the reality is you've got very, very small bits of sediment which are floating. It's often mud or very, very fine sand. It's very light. It can float along and it makes water look a bit murky. In fact, if you look at the sea around our coast in Kent, you find that the sea is murky. That's because it's full of fine bits of silt and fine sand that are just floating around. It looks messy, looks polluted. It's actually just muddy. And then we have solution, where chemical processes have been at work and rocks have been dissolved into solution. And you would find this happening after chalk or limestone have been dissolved and the rocks have turned into a solution and they're flowing along. The additional type of transportation is called longshore drift, and we'll explain that more again later on. This is all due to winds and waves washing up, and then which is called swash, washing up the beach, swash. And then as they come down the beach, as the waves wash back down the beach, that's called backwash. And there's a zigzag movement which actually moves sediment along the shore, and that is also a form of transportation which only happens at coastlines. Finally, we'll look at deposition. Deposition is all to do with dumping or setting down of material. And for this to happen, you have to have a loss of energy because, as I said to you, erosion happens when there's lots of energy. That is the most energy intensive process because you have to have energy to erode and to smash things up and break things down. You also therefore have to have quite a lot of energy to move things along, to transport things around. And when you lose that energy, that's when stuff gets dumped. So if you think about a beach by nature is a depositional landform because it was dumped. It's been dumped there. There's nothing moving it. It's just there. But it wasn't always there. It was once those stones or the sand was maybe once cliffs, or maybe it was in rivers. It got moved along and it gets stuck there. So this is all about when the wind, the ice, water loses energy and can't move material anymore. And this can build new landforms. There are three main ways that deposition can happen. For example, if waves enter a shallow or a sheltered area, mostly, they become quieter, become less energetic, and then they can deposit material. A clearer idea is when the winds become lighter. Lighter winds produce less energetic waves, which can then deposit material. Rivers, when they're flowing fast, they can transport material and erode material, but when they slow down, they lose their energy and they dump sediment. So for example, if it's been quite dry, your river sort of is drying up, the flow is slowing, and you can start to get mud dumped. If maybe the river has been going down quite fast through steep landscape and it starts to become a flatter surface, a lower gradient, it can slow down and then you can find that material is dumped. Or finally, if there's a dam and there's a big reservoir, as the river flows into that reservoir, it's going to suddenly hit the reservoir water, which is sitting there. It's going to stop, and that's going to cause the material the river to lose energy, and it's going to dump its material. So that's our types of deposition. This landscape, we could think about which geomorphic processes could be at work here. Well, first of all, I can see a beach. That beach has been dumped there, so that's deposition. These cliffs are quite vertical, so maybe some weathering is happening on these, and then bits of rock are falling off and landing down onto the beach down here. Well, there's also an arch, and this arch must have been due to some process of erosion, for example, hydraulic action or abrasion at work. But you've also got some cracks here, and these cracks would have actually have been formed by weathering processes. Mass movements would have happened when rocks fell down onto the beach. That was a mass movement, and that would have been a rock fall. And if we think into the future, what could happen next? Well, I'm sure you can imagine this arch could eventually become a lot higher, and this gap here could become thinner and thinner until this archway collapses in a mass movement. So if you look at a landscape, at any landscape, you will actually see all of these different types of geomorphic processes. You'll see weathering, you'll see mass movements, you'll see erosion, transportation, and deposition. And the best geographers are able to look at a landscape and then apply that understanding to be able to explain how it's changing, why it's changing, and then to predict how it might change in the future. And that is the end of our PowerPoint.